All right, let's talk about procedural blocks in System Verilog. Because if you're writing executable code inside a module, that's where it's happening. Now, there are two major types of procedural blocks: initial and always. Let's break them down one by one. First up, the initial block. As the name suggests, this only runs once, right at the start of the simulation. Once it's done, it never runs again. This makes it great for test benches, initial conditions, and debug messages. But here's the catch: it's not synthesizable. That means you cannot use it in actual hardware. It's strictly for simulation purposes. Now, contrast that with the always block. This one is synthesizable, meaning it can be turned into real hardware. There are different types: always, always underscore FF. FF stands for flip-flop. All right. Always underscore com. Com stands for combinational. And always underscore latch. But regardless of the type, all always blocks have one thing in common: they run in an infinite loop, restarting once they finish executing. Most of the time, we use an event trigger, like passage clock. So the block runs whenever that event occurs. This is key for modeling sequential logic. And one more thing: what if you have multiple statements inside a procedural block? You can't just list them out. They need to be grouped using begin and end keywords. Think of it like using curly braces in C or Python indentation. This ensures everything inside the block executes in order. So, to sum it up, initial blocks are great for simulation, but they don't get synthesized. Always blocks are used for real hardware and can describe both sequential and combinational logic. Understanding when to use each of these is important for writing system Verilog code that actually works in both simulation and synthesis.